about the channel coding. Okay, in 5G we also introduced two new coding method, which is LDPC and polar coding. In 3G and 4G, turbo coding is used. But turbo coding is good. Okay, at that time for 3G and 4G. But for 5G, we want to have much more data, much more speed. Then turbo is not suitable any longer. So for the user plane, LDPC is used. Okay. The LDPC is better for bigger data. Okay, for high speed. And for the control plane, okay, control plane is a control message, small packages. Okay, polar coding are more suitable. Okay, polar coding is better for low speed. So this is about the coding. Coding is just so we get some redundancy bit. Okay, in the information, with some to have more protection. Okay. And to make the better efficiency, also in 5G, F-OFDM is used instead of OFDM. Okay, OFDM is for 4G. Okay, for 4G, and for 5G you have F-OFDM. F means filtered. The filtered OFDM it has a much better performance filter used. It can enhance the spectrum efficiency. I can see this picture. The yellow color is OFDM, and the red color is F-OFDM. Now, the F-OFDM is, you can see the curve is much sharper. And its frequency spectrum efficiency is much higher. Now, let's see the comparison. For the bandwidth 100 megahertz, and using this 30 megahertz interval, 15 kilohertz for the subcarrier, then the TTI is 1 millisecond. This means 1 millisecond. Okay, 1 millisecond. While when we are using 30 kilo for the subcarrier, then the transmission interval is 0.5. Okay, and 60 hertz is this one, and 120 0.125 okay, millisecond. Using different bandwidth of the subcarrier, they have a different transmission interval. Not like LTE. LTE only have the first option, this one. Okay. For 5G, we have 1, 2, 3, and number 4. We have 4 options. So it can adapt to different services. And it has the more responding, quicker speed for responding. Okay. And self-contained slot, also for low latency. This is for the URLC service. In fact, this is not realized yet because this has very high requirement for the user equipment, for the mobile. But let's try to know the concept. The self-contained time slot means the time slot has uplink and downlink information both. Like in the LTE 4G, the time slot can be only uplink time slot or downlink time slot, only one of them. But for the 5G, we can define such time slot. This time slot, some part is for downlink, some part is for uplink. Okay, this one, downlink data, and then a small part for uplink for the confirmation. Okay, for the acknowledgement. Okay, and for uplink, it is uplink data. And the small part is for uplink scheduling. Okay. So in this case, the responding speed can be much faster because uplink and downlink almost happened at the same moment. Okay. This is usage for the self-contained slot. Okay. In the future, URLC, this will be used. Okay. So this is all of these techniques, okay, introduced. So in this class, we have mainly two parts. One is for the network architecture part, to realize the 5G's purpose, we need to do some adjustment about the network architecture. And the second part is that also we need to introduce some new technologies of the air interface. Okay? And for the architecture part, our network structure, there is a NSA or SA. Okay? And also we have a CUPS, that is the control plane and user plane separation, okay? So that we can deploy the user plane very flexible for the sometimes it's for the delay, sometimes it's for to save the bandwidth. Okay? And also about the service-oriented architecture, okay? And the network slicing are also very important for the 5G's target. And for the wireless, we have a DRAM, CRAM, and Cloud RAM. And nowadays, most is using DRAM. Okay? And in the future, it will migrate it into the Cloud RAM. That is the CU and DU separated. Yeah. And for the barrier network, layer 3, think. That is that the layer 3 network sync down to the edge. Okay, sync down to the access layer. So that's about this architecture part. And for the key technologies, first one, for higher rate, we have the large bandwidth. The 5G's carrier can be 100 megahertz, okay, for sub-6G, okay, and for millimeter wave, one carrier can be 400 megahertz, okay, the large bandwidth. And MIMO can provide the multiplexing, spatial multiplexing can greatly enhance the capacity. And the higher auto modulation can carry more data, okay, for higher throughput. And LDPC code also are very suitable for the high-speed coding. Okay, this is for the high speed. For high spectrum efficiency, the new one, F-OFDM used future. It makes the radio frequency spectrum efficiency much higher, okay, from 90% to 98%. And also a flexible frame structure adapted to different responding speed. And for the coverage enhancement for SUL, uplink and decoupling, okay, to enhance the uplink coverage for the C-band. Okay. And also method MIMO, okay, is the beamforming to concentrate the energy pointing to our target. Okay. And for low latency, we have the CU-DU separation, okay, our DU or CU to the local DC or even to the maybe edge DC to reduce the responding time, okay, low latency. And a self-contained time slot, this is useful for URLC, okay, which can also reduce the responding speed. That is to say, to reduce the latency. Okay, so this is all about this part, our 5G network architecture and new technologies. Thank you very much.